Besides volunteers, everybody that worked on and volunteered on Security Onion Con yesterday as well. This is and continues to be one of my favorite events. So thanks. It's been a good weekend so far. Hopefully everybody here is having a good time. So yeah, I'm Paul Melson. I work for Target and I hunt bad guys for them for a living. This project, though, isn't really so much about my day job. We're going to talk a little bit about one of my side projects. I actually shared for the first time here last year kind of the inner workings of a project I have going called Scumbots. And it occurred to me I should just do like a real quick overview. So Scumbots is a pastebin scraper and Twitter bot. It looks at new pastebin uploads in near real time. Started out looking for Windows PE files and then analyzing them to see if they were known families of malware. It still does that, but last year, actually, like the morning of my talk, I committed to prod the first of what would be kind of the PowerShell hunting tools. And so now that stuff's been up for almost a year, I want to talk about some of the lessons learned in hunting PowerShell kind of on the open internet, because it's been sort of an interesting year. So, but first, let's level set on hunting. Plus, I don't think you can do a blue team talk without quoting David Bianco. So here's my obligatory David Bianco quote. It's not the pyramid of pain. You're welcome. So hunting is any manual or semi-automated method of finding new security incidents. And I'd say, right, like David, when he came up with this, was thinking in terms of this is a blue team operation within the context of a particular network. But I would also encourage you to consider the possibility that one, incidents are not always observable only within the victim network, and two, that hunting is a thing that you can do out on the open internet, and the more of it that blue team does, the better we will get at wrecking bad guys' days. So let's talk a little bit about the desired outcomes that we have for our hunting initiatives, though, right? So first of all, in this particular case, I'm out to find malicious code, right? I'm looking at static artifacts staged on a particular site. These techniques and tactics could be reused in other venues, but we're looking at code that's going to be pulled down and run. We're looking, in some cases, to discover previously unknown malware. So we're casting a wider net. I don't want to go for only stuff I already know about at a detailed level. I want to cast a wider net and understand, find things that I maybe didn't know about previously. Also want to take a look at threat actors and their behaviors, right? We're catching them kind of in an early phase of the kill chain, and understanding timing and particular tool marks, and particular, because we don't, in open internet hunting, you don't always necessarily get to understand sort of victimology or even necessarily the end game, but getting a sense of where common infrastructure exists, what behaviors they exhibit, and right, people are creatures of habit, right? Whether they mean to or not, they generate a signature and they leave their mark on any operation they undertake. And then finally, right, building new detection logic. So let's talk specifically about PowerShell and trying to find bad PowerShell. So PowerShell comes with 10, these are the 10 most commonly used obfuscation methods that I see with PowerShell code. And the reason that they're the most commonly used is these are natively supported. Now, are there others? Yes. Are there variations on these? Sure. But this makes up the majority of what you're going to see in the way of obfuscation taking place in and around PowerShell. So base64, null padded base64, I differentiate the two because they get used differently, but also being able to tell when you're looking at something that's binary data versus text data, even when it's an encoded format, has a certain amount of value. Compression, hexadecimal and decimal encoding, because PowerShell can do some interesting things by being able to pull in and leverage native .NET capabilities. It also has this horrible mode where it can create a byte array that is mixed decimal and hexadecimal, and you can read it, but good luck building an automated parser for it. It's like the meanest thing ever. XOR, native XOR happens in PowerShell. Fortunately, if you don't re-implement XOR, XORs are single byte keys natively in PowerShell, like if you do it inline, like the little bxor command. So that's beautiful because single byte XOR is highly detectable and reversible as opposed to multi-byte. So those are the encoding, and then string manipulation, which includes things like Daniel Bohannon's obfuscation tactics and techniques, so backticks and some of the other kind of character escaping and spacing and things that you can do. String concatenation. So string concatenation and reassembly can go from simple things like taking a keyword that we might be looking for and just breaking it up and then putting it back together with quotes and pluses. It can also be order reassembly using array and array orders, things like that. String reversing is a native functionality that PowerShell has, and also character replacement, right? So we can build a string that might contain a payload, but then we change this character value to that character value, and then at the end we put the right character back in place so that string-based detection gets harder. And so it's important to kind of, so this is just a level set. We'll kind of get back to why this matters a little later. So I want to talk about, so I came up with an analogy, one that I thought might land, because I'm in the South and at a security conference. But for those of you not familiar with spirit distillation, the process of distilling a spirit, right, it's actually a great aspirational model for how we ought to think about hunting and detection development. So you start with these very large quantities of raw materials like water and grain and so on, and you go through these kind of iterative processes that refine and extract and simplify and enrich the raw materials until what comes out the other end are these small quantities of high quality, highly prized outputs, right? So if you're operating a still, that might be whiskey. And if you're operating sort of a detection, like a hunting to detection pipeline, right? You're going from lots of bulk raw data into a model that results in hopefully high integrity detections. So here's a visualization that simplifies it and breaks it out into taxonomy that I like to use. And this actually aligns pretty well with kind of how I've architected ScumBots, right? So we have a lot of raw data, which is literally everything that gets uploaded to Pastebin. We do a little bit of metadata selection, but then we're going to apply keywords and pattern detection to the actual paste as they come down. Now, that's highly prone to error, and that's okay because then we have what we end up with on the outside of that is sorted data, and we put that through type validation. In particular, if we're looking at an encoding type, we're going to attempt to decode it. That's probably one of the best deterministic ways to validate that we properly detected a piece of encoding is can we apply the decoding and actually get valid values out the other side. And especially for things like base64 that have kind of padding and checksum capabilities, right? Like you might, there are some things that really lend themselves to this. And then finally, right, now we've got, kind of a targeted data set and we can apply maybe more specific and targeted logic to understand the threat and or understand the particular attributes of that data that we want to analyze and pull out. And then coming out of that, we can build some high integrity, high fidelity detections. But what happens when we're dealing with obfuscation is that you have to have this layered approach. You have to work in rounds. So that's my premise, and at this point I'd like to kind of pivot into a handful of case studies, things I found out on the internet, on Pastebin. So let's talk about ransomware, because who's not talking about ransomware? So Boron ransomware is a Russian ransomware kit. I don't know much about the actors or necessarily their intended victimology. I don't think they probably know much about their victimology either, other than hopefully people with computers that will give them money to get their computers back. Ransomware profit model, fairly simple. So, but one of the things about Boron is that, so it's loaded via PowerShell, and at least one of the actors involved is staging their droppers on Pastebin. So they have taken and modified invoke psinject.ps1 from the PowerShell Empire kit. The payload is a base64 encoded PE payload. It's a combination of base64 encoding of the actual Boron ransomware payload and some simple string concatenation. And they randomized the variable names in invoke psinject.ps1 in hopes of making it a little bit harder to detect. I give them like a 2 out of 10 in terms of obfuscation. I mean, this is this is the code. So random variable name all the way at the top, but we get right into, I mean, it's fairly obvious that that's a big, blob of base64. If you stare at base64, you can see TVQQ, so PE header. Lots of A's, so lots of null, so it's probably a binary file. We get down here into the actual loading code that will, that goes through and kind of handles the conversion. It does a few other interesting things, but this is all like, variable names and everything in here. That's all like true to the original PowerShell Empire code. They did, unlike many other actors, they did strip the comments out, so there's that. But then down here, all the way at the bottom, you can see, right, like invoke, and then here's the randomized variable name, and then the other variable name, right? So if your detection rule keyed in on exactly that default from PowerShell Empire, they would bypass it. But let's talk about detection performance, because that's actually kind of what we're here to talk about. So over this family of malware, I found 34 samples over the last year. And along those 34 samples, here are the string matches that we hit on. So you get string reflection assembly name hit 68 times. So that's perfectly 2 per sample. From base64 string hits once per sample. And then we get, so we got 31 that hit on one variation of TVQQ and another one TVPQ, because it's a DLL that they're loading into memory. And then another one, and then that bottom string there, this is a backstop I use. I'll talk a little bit more about it later, but that is a substring of, so if you've ever looked at a Windows PE binary, you know this program cannot be run in DOS mode, that message, except it's not always this program cannot be run in DOS mode. Sometimes it's this program can only be run in Windows mode, and sometimes there are some like excellent typos, and I mean, that string doesn't even really matter, but it's just kind of always there because it's a convention. So for whatever reason, his program shows up in almost everything. So by making a couple of variations on base64 encoding of that, we can roll up stuff. And because, and I'll talk a little bit more about why that's a nice piece of detection later. But so anyway, so moving on, but I'll come back to this also. Kibby ransomware. Basically the same thing, just different family of ransomware, different actor, staged on pastebin, using PowerShell. Also based on Empire, but instead they picked invoke reflective PE injection. They didn't bother with string concatenation, although we could argue if you'll, right? So is that really string concatenation, or is that just PEP8 compliance? So pseudo-random function, so like they did less work. The Kibby folks did less work with their obfuscation. So you can see like up there, it's still function invoke. Everything else is as it was, but that function invoke, one of the things that uniquely identifies this builder, so I guess I'm burning this piece of attribution, is that it's always invoke dash and then 15 uppercase letters. No numbers, no lowercase, always uppercase letters. So. And then here's some more of the actual code itself. And so you can see down here, not PEP8 compliant. It's just one big long string. And they called it PE bytes 32, just like in the original PowerShell Empire. Attempts an AMSI bypass, tries to turn off script block logging. Empire things. So let's look at keyword performance for this one. So different actor, different piece of ransomware, different decisions, but they stole code from roughly the same project, and some interesting things persist. So at 161 samples, of soda no Kibby as of like a week and a half ago when I finished this part of the deck. There's lots more now. I saw some just this morning. But 161 samples, 2-to-1 ratio on that system reflection assembly name, 1-to-1 ratio on from base 64 string, and in this case, the TVP, we only see 2 DLL payloads and then 159 of the regular TVQQ style PE headers. So what we end up with though is this ratio that we can describe, and it persists between the loader used by actor A with ransomware A, with the borrowed code that they had, and actor B and ransomware B with the borrowed code that they had, even though I think they're operating independently. This pattern persists because they stole code from PowerShell Empire, so that's awesome. And what you can describe is basically these loaders are going to call system reflection assembly name twice per run from base 64 string, once per run, and they will contain one base 64 encoded PE file somewhere in them. So strings that describe that are also valuable. So that pattern repeating means that we could go ahead and use something like a Yarrow rule to go ahead and build detection for that loader. So you wouldn't hunt with this, but this is actually pretty decent detection. This works on about 3/4 of the actual PowerShell loaders that come as part of Empire Agent. You don't have to take a picture or write this down. So at the end of the talk, I have a link to my GitHub, and this is out on GitHub as of this morning, just as a sample for the talk. So pretty simple strings-based approach, and just using a little bit of logic in the actual condition to dial that in. So, all right, let's talk about a few things that are a little less structured, a little less neatly. Well, let's just say it's not PEP 8 compliant. So PowerShell keylogger. For whatever reason, there has been just a glut of garbage PowerShell stuff being used by attackers on Pasteman lately, and this is one. So it started out, so in 2016, a blogger named Coder Girl published a sort of a hypothetical, hey, what would it take to write a keylogger in PowerShell? And so she did, and the blog post is fine. Somebody took it and modified it so that when it's done writing to the local file, it then exfiltrates the contents of that file as an email attachment over email, right? Like over TLS, like SMTP TLS port 587. The code itself is not obfuscated or encoded, and there are multiple variants, English and Spanish. A lot of them include her comments. There's a typo that was made at one point that persists. So there's some interesting lineage, even though there's not much code. So this is an example of the actual PowerShell keylogger that I found. So like right there at the top is the config where we set up the subject and the to and the from and the password. And then you can kind of see how it's hooking these different functions from user 32 DLL and starts to build like an endless loop that captures keystrokes and just writes them to a text file in kind of a garbage format. So I know what you're thinking, right? He's collected over 100 samples of these keyloggers that are intended to steal victims' information, and he has all of the credentials that go with them too. There's no way the next slide is just a list of all the email addresses and passwords belonging to the bad guys, right? So here we go. So I have not, and you will not, because we would not violate CFAA, logged into any of these accounts, but there they are. For the room and eventually the entire internet to see. And I know now what you're thinking, okay, cool, but he's definitely not gonna point out all of the pen tester accounts that were used that rolled up in here. And there's absolutely no way he's gonna point out all of the typos and do-overs either. So that's fun. Bad guys aren't always the best. at what they do. So let's talk keyword performance for a minute. So what I really rolled this up on was hunting for convert to secure string, which is so convert to secure string is a simple like encoding encryption function that PowerShell includes natively to be able to handle passwords securely. So what's funny about this, of course, is that that they put the password in clear text in the payload that gets delivered to the victim, but they have to do convert to secure string in order for the actual like SMTP message handler that PowerShell uses to like authenticate to Google. So they like right, like you must handle the password properly like after you're done with your attack. So we catch convert to secure string pretty reliably. PowerShell dash. Some of the implementations have just sort of a little bit of a variation on how that gets called. PowerShell.exe, PowerShell dash with the a new object system IO. I would have to go back and look at why that one only once. I also don't know why system.net fires. But so you can see like, so we rolled it up on basically a single keyword. It reliably works because they have to have it in order for the actual like exfiltration connection to happen. But this isn't like, so this is good hunting logic. It's pretty poor detection logic. Like you would definitely not want to deploy convert to secure string to all of the script block logging that you have turned on in your environment. Unless you don't have it turned on in your environment, in which case then you knock yourself out. 0 false positives, 0 true positives. So let's talk a little bit. So another kind of similar piece of garbage that I see a lot is a Wi-Fi password extractor. And this one, so it coded by whisper groups. I don't know what that means, but it shows up in most of the samples. So whisper groups, congratulations. You are almost as good at writing code as I was when I was 12. So because what they wrote was a batch file that uses certutil to decode and run base64 encoded PowerShell. So first giveaway question, why is it stupid that they use certutil to execute base64 PowerShell code in the back? Yes, so the answer for those of you that couldn't hear it is that PowerShell can just natively execute base64 encoded PowerShell. That's correct. So would you like the tap or the Wi-Fi NIC? All right, thank you. So yes, that's 100% correct. There's zero reason to, so certutil run from the command line is suspicious as all get out. And they do it anyway because they don't know how to run a dash encoded command with PowerShell. But you can see here, we'll actually look at the, so same thing, by the way, it steals the passwords from WLAN profile object, and then exfils them over port 587. So this is what it looks like when it shows up. So it echoes a base64 string that is a valid PowerShell, well here, there. So now one PowerShell execution instead of a cmd.exe with an echo with certutil, then followed by PowerShell again. So it's pretty hilarious to watch that one run in Sysmon. It's really noisy. And so this is the actual code itself, pretty simple. Anybody else want to point out anything else that's potentially problematic here? Like how RM doesn't work in batch files. But anyway, but like I said, well, so here we are again, more, and so you can see though, again, we rolled them up, new object system net, network credential, and then, where is it? But somewhere up there, we've got the same secure string we have to use to generate the valid credentials. But so it works. Like the exfil method is basically the same between these two, even though they do something different. I don't know, and I've seen literally hundreds of these things, and I don't know, how valuable is it to steal the Wi-Fi creds off of a device, staging it on pastebin. I have a theory. My guess is that somebody's teaching it in a class. So anyway, here we are, and I know what you're thinking. There's no way that the next slide is all the passwords, but of course it is. And there's no way I'm going to make fun of the red teamers. So it would appear that just based on the name of a few of these, Wi-Fi stealer, exploiting ducky at gmail.com, this is probably tied into like Bash Bunny and rubber ducky attacks. All right. Oh, typos and redos, and then this one is for my coworker Adam. I see you, Adam. I see you. All right. So keyword performance on this. So interestingly enough, so remember we added they added a layer of obfuscation by base64 encoding the payload. So instead, this time we're hooking up on base64 encoded variations on system.net. And a little bit about base64 real quick is you can take a string, and depending on the position of that string relative to other characters in that string, so a substring inside of a string that you're encoding with base64, and depending on that position, you'll end up with different values, right? Because base64 essentially creates 3 character blocks of encoding as it goes. So anyway, 3 different possible ways to say system.net in base64. We have detection for all of them, and so what you'll see there, if you add all of those up, is that they basically equal 2x 82. So system.net occurring twice in there in base64 encoding, and we had only three of them out of the 82 detected with PowerShell.exe space dash because. And this is probably another interesting tool mark because 79 of them, it was PowerShell space dash. I don't know why, but I also don't know why they use certutil, and I don't know why, and I also don't know why I don't have a rule for certutil. I'll be fixing that. Okay, so kind of looking forward a little further. PowerShell Empire agent. We talked about PowerShell Empire droppers earlier. They're being used by ransomware. PowerShell Empire agent is the RAT. It's the implant portion of Empire that's implemented fully in PowerShell, and I see a ton of this. So it's an open source. Empire is an open source post-exploitation framework. It's favored of red teams and actual criminals the world over. Actually, some of the stuff that the bot tweeted out earlier this year was Fin6 with implant activity related to handoff between another threat group and their C2 in furtherance of rollout of Ryuk ransomware. So that's fun. Empire agent implemented fully in PowerShell. Dropped via PowerShell one-liner, which is obfuscated, and then there's camel casing and a few other things that occur in there. But base64 encoding. So this is what it would look like when you see it for the first time. So a lot of base64 encoding. This is null padded base64. So if you decode this, every other character is a null. So it prints out nice and normal looking, but if you actually decode it into like a bytes object inside of Python, it's twice the size it needs to be, and every other character within it is a null pad. Which is interesting because that's not a thing that gets read normally easily by other functions. That's a thing that's almost exclusive to, like, there are other applications, but it's usually a pretty good tool mark for PowerShell. So if you encounter base64 that doesn't, like, so it's super handy when it's just PowerShell, dash encoded command or dash E or dash ENC, or actually dash EN also works, it turns out. But anyway, if you find something that's null padded base64, chances are the intention was for it to be run by PowerShell. So before you even get to decoding, we can leverage that information. Here's what it looks like when it's kind of broken down and torn apart and beautified. But you can see the camel casing in here. And over here, this base64 encoded block. So that's, again, null padded base64. And that contains the URL that points back to the C2. So you decode that, you get the C2 out. And there's a few other telltale signs. Same thing as other parts of Empire, tries to disable AMSI and script block logging before it downloads the actual persistent payload. So 139 samples of this that the bot rolled up over the last year and change. 120 of them based almost exclusively on that PowerShell dash. So that's not great in terms of detection performance, right? Like, it's an okay hunting string, but like we're not really getting into the meat of why Empire Agent is there. Now, I have some stuff downstream from the actual, the initial funnel that does a nice job of pulling the stuff apart and automating the analysis and getting the actual details to the Twitter bot so that y'all can read it. But from base64 string, system.net, new object, system.io. So these are all, right, like, so these are different pieces of PowerShell functionality. So from base64 string says I'm decoding some base64. That's always potentially interesting. System.net, begins to reference the network connections libraries. System convert can be a decoder of types. New object, system.io means we're going to write an object or at least a byte stream object that might not be a permanent thing on a file system, but potentially useful. We got a couple of -B XORs. In a handful of these cases, there was some single byte XOR obfuscation that one of the actors applied, and we rolled that up this way as well. And then base64 encoding versions on PowerShell and from base64. All right. So again, though, like the bottom line is, so one, this is how my detection performed over the last year, and two, making the point that like this is not as good as I would hope it to be. Like it's not high fidelity, and moreover, it's fairly fragile, right? PowerShell Dash, it wouldn't take much for them to take all of the payload they need to deliver and just do something else, rename the executable on the other end, or just include that in a different piece of the handoff that's not visible here, and all of a sudden, like my hunting like starts to break down. So Meterpreter and Cobalt Strike. In particular, I'm talking about a family of capability here that involves PowerShell scripts that load shellcode into memory to execute network callback. In most cases, it's reverse shell. In some cases, it's payload download and delivery. But either way, I'm grouping these two things together because both Cobalt Strike and Meterpreter leverage heavily the same like tactics, right? There's a lot of similarity in code, and so being able to differentiate them at a high level becomes complicated. It really requires sort of lower level analysis to be able to differentiate. And I'll show you a few things from an analysis perspective as we get down, but the actual PowerShell droppers are very closely related. So again, favorite of red teams and actual criminals the world over. I kind of explained this. So Cobalt Strike, Metasploit, and Unicorn all kind of, and a few things of unknown origin that I rolled up. base64 encoding, XOR, obfuscation, string concatenation, compression, all kinds of variations on this. Again, and here's the thing, right? Like, would you be able to tell by looking at this, like the actual staged payload, being able to differentiate this from an Empire Agent payload? Almost impossible. Even mechanically and certainly visually, they look pretty much identical, right? It's just more nullpad base64. So this is. So when we decode this first round, we get this next round, so that's helpful. In this case, that happens to be gzip compressed data that has been base64 encoded, which means that trying to detect the actual payload code through the first round of base64 encoding is impossible, right? I mean, it's not impossible, but it starts to become a physics problem, quite honestly, when we talk about trying to do that with taking a string we're interested in its presence and iterating it through multiple rounds of decoding and encoding. I'll talk more about that in a minute. Okay, so now we've decompressed it. Here we're actually getting the opportunity to see some code that starts reflective loading. And this is base64 encoded shellcode. So this is x86 shellcode. And if we go as far as to actually decode this and put it through PowerShell X-ray, so these are the actual hex bytes, but you can see up there in the strings the tool marks. So at the very end there's the IP address, there's the URL, and then the user agent string. And the fact that it has a user agent string is a pretty good tell that what you're looking at is Cobalt Strike and not Meterpreter's HTTP download. But almost all of the system calls, like the actual preamble and the rest of the opcodes there, basically identical. The code that I used to parse this out works the same and is like 98% accurate, whether it's Cobalt Strike or Meterpreter payload. And I suspect that's because Cobalt Strike borrowed from Meterpreter's payloads, but that's just a theory. So keyword performance, 246 samples, and nothing is like a definitive roll-up. By the way, the asterisks represent sort of case variation. So camel casing, especially as you get into Empire Agent and some of the Meterpreter stuff, is used to throw things off. So, you know, case insensitive detection of strings is helpful in these instances. But you can see we're getting there with most of the same kinds of things, right? Except the only thing that's potentially unique here is the use of create thread. We haven't seen that much previously. That seems to be kind of a thing that's sort of unique to the Cobalt Strike loader and to Unicorn. All right. So, but again, you know, not a lot of high fidelity detection, and the stuff that has the high hit rates at the top, the stuff that makes up the bulk of the actual detection that push this into the actual hunt pipeline in the first place, those string matches are super fragile, right? It's just the declaration that this is PowerShell code to begin with. So that brings me to where I'd like to go next, which is making a case for advanced pattern detection. Wanting to move on from just string-based detection. String-based detection, by the way, is performant. Like you know, and you shouldn't. I don't want to throw the baby out with the bathwater, but when we're specifically in the arena of PowerShell, you're focusing on almost all but one of these threats leveraged some form of encoding as obfuscation. And multiple rounds of encoding as obfuscation made it very, very difficult for strings to remain performant. So as we talk about that as a problem, right, like as you stack and iterate over encoding and obfuscation in arbitrary quantities and orders of operation, as you get deeper and deeper into the number of techniques applied simultaneously, it becomes almost impossible. And the graph, order of magnitude graphs suck. And this one sucks because at 2, we're already, at 1, so at 0, we're at 17 strings. At 1, we are at 65 strings. At 2, we're at 300 strings. At 3, we're over 1,000 strings. At 4, we're over 20,000 strings. But the thing is that we go into the millions of strings. Like, so it's more like a power of 3 or 4 in terms of like the number of strings you would have to have in your actual detection library to cover all the possible use cases. So instead, I decided I would propose a new piece of technology. It's proof of concept. The code's actually out on my GitHub repo for you to play with, and I've started implementing and incorporating this into the pastebin scraper. So part of that's been updated. Few things to work out there to make it performant enough for pastebin. But so MLSGM is the new technology that I'd like to roll out. And I know what you're thinking, right? Machine learning signature generation mechanics. No. So what if I didn't need a PhD to generate a machine learning model? So that's ultimately this talk. So how does MLSGM work? So we're going to define so encoding is particularly easy to attack. If you've ever done any cryptanalysis, you kind of understand, right, like being able to map out all of the possible values that a particular thing is going to have is super useful. Encoding is even more attackable than that because we know that in order for encoding to adhere to the rules of the already built-in functionality, it has to do certain things. So in the case of base64, it has to adhere to a particular character set. We calculate the similarity between the unknown file that we're analyzing and the known character sets. And with just a little bit of simple statistics, we can go ahead and look for simple variations on obfuscation. And one more thing. Going back to PowerShell characteristics, when we look at those string manipulation things like DOS-fuscation, string concatenation, string reversing, like they can't ultimately change the character set that's used, right? You can break up an encoded string and make it hard to understand or detect what that is until you've actually executed the code and put it back together. But identifying the encoding that's being used, none of these things actually impact that. Character replacement impacts that, but we can sort of manage for that too, because the beauty about base64 in particular is it occupies so much of the valid ASCII character space that you can only do so many rounds of replacement before you've ultimately broken. And which that happens quite a bit. Like, that's fairly hilarious that people, like some of the adversaries out there that have tried to do like character replacement but don't understand that base64 is case sensitive and that really matters. Like, so they'll break their payloads on deployment because it decodes as something different. It's awesome. So anyway, it's not really magic, it's just math. And finally, we can use standard deviation to pick up on things like compression, encryption, padding, and some of those things. So live demo time, I guess. All right. I have to. All right. So this is the actual code here, and you can check it out on GitHub, but I'm going to walk through it for a minute. So what I have over here, though, is a sample set of pastes, 1,000 of them to be exact. And these are just randomly selected pastes that the paste files that the bot has already taken. They're all kind of raw. Right, so here's an example of one, right? And then I built a little wrapper for the demo so that we could grind through them all easily. So it's just a little bash script that will loop through them and tell us how long it takes to run. So let's see if I can explain the code faster than the demo can run. The answer is probably not. All right. So the first function that we're really dependent on here, we define all the character sets that we're potentially interested in. We go look for a perfect match. If you read the file in and everything right out of the box automatically matches the character set, then we're golden, right? Like that's a one-to-one match on encoding, and we can move on with our lives. I did that almost more for performance than anything else. This is the actual MLSGM function, all 20-some lines of it. So not a highly complicated TensorFlow model or anything like that. It's actually fairly performant. This box is not, well, one, it's re-implementing all the Python, literally every file it scans. It's reloading all the libraries and everything. So it's not optimized at all. But this works fairly well. And mostly what we're doing is just going in, counting the size, how big is the file that we're looking at, how many characters does it have, and what percentage of the bytes in the file that we're analyzing match the character set that we're looking at, and then we're making some judgments against that to basically determine how likely is it that the thing that we're looking at is base64 encoded in this particular case. And so I came up with kind of 3 use cases based on things I've seen. So is it a base64 binary file, or does it contain, is it likely to contain null padding? That one's particularly interesting because that's you won't get a perfect match on one of those empires hits because you're going to have spaces and periods and things like that in there, but this is a good detector for that. Compression or encryption, where we're looking at a relatively low standard deviation across the frequency of each of the characters within the set. So knowing that we're looking at something that's encrypted or compressed is also particularly helpful, especially because some of the gzip modes don't include a header. So decoding the data, you get a blob, you don't know what it is, but having some idea that you're probably playing with compression gives you a couple of short steps to completing that decoding. And then finally, being able to detect character substitution. So when somebody replaces all of the A's in a base64 encoded file with the pound sign or something, still being able to pull that out and pick that out without having to do perfect string matching on that. So that really, in a nutshell, is MLSGM and the use case that I had. So at this point, I'd like to take any questions from the audience. Okay. So the question is Pastebin the only place that I'm seeing PowerShell malware? No, it's the only place that I have a scraper deployed, but I can definitely give you examples. So we see it on paste.ee, Ghostbin, GitHub. GitHub has kind of a problem. I'd really like to, I think that's probably where I'll look next in terms of being able to automate collection, because there's some stuff GitHub offers up that we might. Yeah, and I'm just interested in collecting and analyzing this stuff from, one, from building a library, and then two, for doing some indicator extraction and building some intelligence. For Blue Team to like blocklist GitHub repos? Yeah, absolutely. No, and so what I would pose is, right, like the Blue Team play, right? Because Pastebin's another one, right? Like there's a chance that you've got, I mean, Pastebin, maybe you could have an argument, like you could have a discussion that like the threat's higher than the ROI on the business. GitHub, for basically every company, it's upside down on that. There's some threat there, but the value to the company is just going to be way too high, especially if you have any software developers. So instead, like the argument I would make is that you want to get in line for all of the files that are kind of coming, ingressing into your network as downloads or email attachments or any of those things, and start applying detection and analysis to those, because a lot of the kind of bad code artifacts that we talked about here are not going to be things that show up in normal source code repositories. So, but you'll probably catch Red Team updating their Kali boxes. All right. Other questions? Yes, sir. Analysis for Go. I mean, maybe if I saw more Go. So I have a sample problem with Go. If you've ever compiled Go, Java said, hey, we're going to make bloated jar files when we roll out, and Go said, hold my beer. Right, and so as a result, though, when you encode like Go malware payloads, like they're literally too large to, like, they exceed the max paste size for Pastebin. So I pretty much never see it there. I have seen and analyzed some Go malware in other contexts, but without maybe the GitHub expansion or some other source, I'm not likely to ever, like, those two things don't cross just because of the kind of the space limits on Pastebin.
So with the support development of Empire and Microsoft push towards core and stuff like that, like PowerShell 4, how do you see this kind of environment evolving over the next few years?
It's a really good question, which is, with Empire being out of development, and so I'll take the first question was, with Empire and tools like that, Empire coming out of development, there are a couple other packages that have been walked away from. So there are, Empire's out there, and you can't pull it back. So bad guys get to keep using it. A lot of the techniques continue to work, and it'll be kind of on Microsoft to kill those off individually, in particular, like the AMSI bypasses, and they've already done some stuff with later versions of PowerShell. I do see quite a few PowerShell 1.0 like downgrade style attacks. So the one thing I would say is, if you have a need for PowerShell in your operating environment, do your level best, like treat PowerShell 1.0 like it was malware. Kill it, make everybody upgrade to 3 or later. No, seriously, it will. Bad guys will. They will. That's a moat they'll fall in. So, second question is, where do I see PowerShell as Microsoft does a better job to kind of cut down and curtail abuse? I mean, at the end of the day, it's pretty powerful. I think we will see some. I think there's still a lot of meat on that bone. So I don't think PowerShell's going away. One, because it's super handy living off the land, and Windows is still kind of the big enterprise server and workstation environment. So, having said that, the .NET and Visual Basic kind of like functional keywords that I use in hunting, like I find a decent amount of Windows scripting host and VB script stuff too. That stuff all still runs JavaScript. Non-binary script attacks or script loading preamble portions of attacks, that's not going anywhere. I think I could probably talk on that topic for a solid decade, if not till I retire. Okay. Trivia question for the giveaway. If I'm looking at a piece of base 64 and it's null padded, what's the character it's going to have the most of? A. Which A? The capital A. All right. That's right, capital A. All right. Thank you very much.